Good day, grade 9. We are going to look at example 2 in your consolidation worksheet, and example 2 has to do with similarity. So in example 2 they give you the diagram and they give you this information. So let's quickly mark the information on the diagram. They give you that BH is parallel to CD and that BC is parallel to HD. So let's mark them in different colors. Just want to get straight lines here. So BH is the line that goes from B to H. And because it's extended, it's a straight line, it goes to F. So that will also include this part of the line. So this is parallel. So put your arrow on that if the line is divided. And that is parallel to CD, which means I have this line here at the bottom. There I have one pair of parallel lines. They also give us that BC is parallel to HD. So let's use a different color for BC and HD and make them red. And say from B to C parallel to from H to D, and because HD is also extended to E, it includes that part of the line. So you will also have that part parallel to that part. That is not so straight, but you get the drift. So it's that whole line. So I've got two pairs of parallel lines that's given to me, and I have to prove now that triangle AEH will be similar to ABC. So similarity, people, we deal with angles. The shape is the same, but the size may differ. So it means to prove that two triangles are similar, you need to prove angle, angle, angle. So this is what we are going to look at now. So let's look at triangle AEH. Just make sure that we know what we are dealing with. So it's from A to E. So it's going to be this part, this triangle here. Similar to ABC, which is from A to B to C, which means going to be this part of the diagram. I've got this. So if I look at this, the small triangle inside the longer one, then I need to prove that the three corresponding pairs of sides are equal. So the one that you can already see is the one that I have in common. Both of them have the same vertex here. Can you see that? So that means this vertex, this part, is common to the small triangle and to the big one. So we have one angle, one pair of angles. So look at other angles and I have parallel lines, and it must already give you the idea. So let's see. Let's look at diagram signals here. I've got a parallel line, pair of parallel sides here. So I can connect them with a transversal, which is this line. And I looked at the angle that is formed between the parallel line and the transversal, which is that one there and that one there. What kind of angles do I have? They correspond in position, and I've got parallel lines, which means that they are equal. So I've got a second pair. But let's see, I've got another transversal here that connect parallel lines. Can you see that from there to there? So if I look at the angles that's formed here, I've got the angle. Let's cross that one from there to there. And the other angle will be this one from there to there. Can you see that they are equal to each other because they correspond? So I've got three pairs of angles. Done and dusted. I just need to write it up now. So I'm going to write it up and say A in triangle AEH and triangle ABC. And I want you to look at the labeling of the triangle. That vertex A is common, so we're going to start with that one because that is the easy one. That is the one vertex of the two triangles, and we are going to say angle A. But it's not just angle A, because angle A is that whole angle, it's just that part. So it's going to be EAH. Let's write it properly. Angle EAH will be equal in size to triangle BAC. And the reason is that they are common in both. So that is an easy one. I've got that one. So let's write for this one and this one. This angle is formed from E to H to A. So let's do EHA. And there's my vertex is equal to BCA or BCH. So let's call it BCA. And the reason is I correspond. So I've got corresponding angles here. And they're equal because BC is parallel to ED. So let's say BC parallel to ED, and you must always put that in because corresponding angles aren't necessarily equal. The lines must be parallel. So my third pair of angles will be this one and that one. So this one is AEH. Here I have vertex E, AEH equal to ABC. And can you see the reason is that also corresponding angles and BC is parallel to ED. So now I've got angle, angle, angle. Therefore I can say, I can conclude that triangle AEH is similar to triangle ABC. And the reason is I have an angle and an angle and an angle. So number A is done. Got that? I proved that they are similar. For this B part, you have to prove that triangle AHF is similar to ACD. So where is AHF? So let's just identify. From A to H to F, so it's going to be this triangle here. It's going to be this triangle here, similar to ACD, which is from the A to C to D, which means it's going to be this part of my diagram now that I'm looking. So it's going to be this part. Right. So if I look at these two triangles, that one and that one, once again, can you see that they share a vertex, which is there? So they both have HAF as a vertex, so we have a common angle. We have parallel lines here, so let's look at our diagram signal. I've got a parallel side here, and it's connected with this transversal to that parallel line. So here is my diagram signal, which means that this angle will be equal to that one. Can you see it, people? And then also, I can have a transversal on this side that connects these two parallel lines here. Can you see it? So the angle that's formed between this transversal and that transversal They correspond, so they must be equal. So there's my 3 pairs of angles. So for B, let's write it up. I'm going to say in triangle AHF, and triangle ACD. Start with the common angle, which is HAF. Will be equal to CAD, and it's a common angle. Right, we've got the first one. Then we have, let's go to the second vertex, which is H there, which is this one. That is angle AHF. Now we go AHF. Must be equal to, and that's the one that corresponds is ACD. And the reason is their corresponding angles. And in this case, my parallel lines are BF and CD. So I can say BF parallel to CD. Now, move this up a bit, that's a bit much. Okay, so now I go to this triangle and this one, the last one, which is AFH. Equal to this triangle, which is IDC, and they also correspond. And it's also because BF parallel to CD. So right, angle, angle, angle. Therefore I can say triangle AHF is similar to triangle ABC, sorry. And the reason is angle, angle, angle. So we are done.